Hi, I'm the software developer working on the Robo HAT MM1. Today I wanted to give you a quick tour of the Robo HAT MM1. The HAT is an educational hardware platform for students and all-round useful robotics controller. It has many hardware features and runs CircuitPython and Arduino's C++. So let's start looking at the functions of the board. So starting in the top corner, there is the NeoPixel and serial header up here. The NeoPixel header is for connecting digital or addressable LEDs. You might use these if you have a robot that needs indicators, brake lights, or maybe you want to use a library like LightShowPy. The serial pin is for attaching to a serial port device like the Raspberry Pi. This is already done on the board, so maybe you'll use this for something else. Coming around to the other side, the Robo HAT has analog pins along here which can act as radio controller input. Next to them is the high quality PWM outputs. These are mainly used to control servo motors. I'm sure there's lots of other use cases as well. Down here we have the power on button for when you have a Raspberry Pi connected. You are able to press this button and then the Pi will come on. The Robo HAT has a micro USB connector as well. It serves many purposes. Primarily it will be used for uploading new firmware. It is also used to access the serial console running on the board or the serial console running on the Raspberry Pi, depending on how you configure the HAT. Next, we have the battery input. You're able to connect up to a 15-volt battery to this port, which will power the Robo HAT, the Raspberry Pi, and some low-power peripherals. If you're using an electronic speed controller, you can connect it here. This port is a power pass-through from the battery connector. Using the ESC port also allows you to measure the onboard current through the INA219 current sensor, which reports back on voltage, current and power usage. Here we have the small Lipo battery connector. This battery is charged via the micro USB port. It keeps the Raspberry Pi and Robo HAT on when there is a voltage drop from the other battery. It also provides enough power for using just the Robo HAT and maybe a few sensors. Coming around the board, we have the external connector ports. We have over here the UART port. This is used for connecting external sensors such as communication and telemetry devices. Around the side we have the external I2C connector. Some devices like a pressure sensor, light sensors and others use this port. Then we have the GPS port. This is done to drone code standard and should allow connectors from most GPS devices with a compass to connect in here. Finally, we have the SPI connector. SPI is for higher speed devices such as the IMU and others. This connector is configurable through these pads over here so that you can connect it to the Raspberry Pi directly or connect the processor to the Raspberry Pi. On the production model, we will not have these stacking headers. They are just on the prototypes. As already mentioned, the Robo HAT is very easy to stack on top of the Raspberry Pi. All you have to do is put it on the header and there you go, it's on there. So we'll just go around the board, show you what it looks like while it's on the Raspberry Pi. We have the RC inputs, servos, and the button, the USB port, the power, ESC, Lipo battery, UART, I2C, GPS, and SPI, with the NeoPixel and serial port in the middle. And taking it off is as easy as that. The Robo HAT also works with the Nvidia Jetson. All you have to do is put it on here the same way as the Raspberry Pi and it's all good. You can easily access all the pins on the Jetson while the HAT is on the Jetson as well. You can use the Jetson Nano and the Robo HAT together in your project to form a powerful combination. The Jetson Nano itself is not actually able to control any hardware, as it only is able to provide a small amount of current. So I hope you've enjoyed this small tour of the Robo HAT MM1, which is available on Crowd Supply now. Thanks for watching.